Cool. In this video, I would like to take you through how you can fix problem of missing value or missing data in a data set in SPSS. So technically, I would like this to be a practical course, as I said. So I would like us to move all together. You don't need to write anything. It will just give you a simple guide on how you can fix problem of missing values in SPSS. So what you're supposed to do, we need to use an example dataset which contains some missing values, which is a sample dataset which is pre-installed with SPSS. So what you're supposed to do basically, just get into your file explorer, then go into local disk C, then head into where we have program file, then head to where we have IBM, then click SPSS, then click statistics, then click 27. Then you need to come to where we have sample, then choose English. Then you need to search for telco. So when you just search for telco, there is a telecommunication data which is pre-installed with SPSS, which is an example dataset of a telecommunication industry, which was doing some research about how people are using some telecommunication devices and program, and their various ages, marital status, and their income status. So we shall use this data set. So I would recommend you use this method. I know there is another method which you can use, the dialog box or welcome window in the SPSS, which have this example data set, but just use this method to be at the same par with other people who close that dialog box and decided not to show it in future, and now they cannot be able to get that data set as in the shortcut window. So just open this dataset, which I have opened, so that we run in the same page and be able to do this analysis easily. So when you open this dataset, you can notice that our dataset contains a lot of missing values, which it can be hectic to fix, and in most cases, they result into improper reporting when conducting your t-test. So in order to fix this problem, you need first to know how you can be able to notice that you have missing value in your dataset. So before you conduct any analysis using SPSS, you need to counter check if you have some missing value. So there is a set threshold which missing the amount of missing value is allowable. So there is a set threshold of 5%. So if missing value in a certain observation exceeds 5%, this one is classified as harmful, and your dataset might contain some level of biasism. But anything below 5%, it is not harmful. But I'll show you how we can be able to check if our dataset or the variable which we are running have missing value which is greater or less than 5%, which is the set threshold. So what you're supposed to do, just click Analyze, then come to where we have missing value analysis. Then you can just select use all the variables rather than clicking Control A. You can either click Control A or just select use all the variables. Then don't use any pattern or don't describe anything. Just click OK when you do that. So what we need to focus with is this missing value side. So this univariate statistic basically means universal statistics. So it's just a universal summary of the dataset which we have. So we can see all the variables which we have, and you can see when we check the missing value, you can notice our dataset where we don't have the missing value. Our dataset is a dataset which contains 1,000 observations. That is what the N represents, the number of observation. We have 1,000 observation. So you can notice, like here where we have tenor, we have 968 observation, that resulting to a missing value of 32 observation, which constitute around 32%, which is not a cause of an alarm, since this is around the set is below the set threshold of 5%. So, but you can notice where we have a call for alarm is where we have marital status, where we have a missing value. So we had a missing observation of 115, since you can notice that the number of observations which were corrected about the marital status was 885. So when you take 115 plus 885, it will give you 1,000. So we were missing some respondent or some response about marital status amounting to 115, which is close to 11.5%, which is greater than the set threshold of 5%. So the other core problem is the address of our respondent and their income. So most people hide about their income. You can see it amount around to 17.9%, which is 18% actually. You can come to where we have employment. You can notice we had a count of missing value of 96, which amount to around to 9.6%. We also had retirement. Most people also did not give information about their retirement, which are around 8.4. So other like gender and resident, they are below 5% threshold, so they don't raise an alarm. So when it comes to fixing this problem of missing values in SPSS, we usually have close to 5 methods which help us to solve this problem. And one method is the list-wise deletion. So list-wise deletion technically involves delete of some rows which or some samples which contain some missing values. But you notice this one will not start reducing the number of the samples which you are supposed to carry analysis for. So now this one is you'll be moving from one problem to another. So there we also have another method called pairwise deletion. Also, this one contain a lot of deletion of some pairs. So even this is not a recommended method. I don't recommend it. There is also the mean substitution. Also, this one I don't recommend it. So the method which we'll be using to make this course simple, we'll be using first the regression-based imputation method and expectation maximization algorithm method, which we abbreviate as the regression-based imputation method. We abbreviate it as RBI, and regression maximization algorithm method we abbreviate it as EMA. So, but don't cram this name, it is so easy. So I would like us to get back into our data set. Then when we get back into our data set, in order now to fix this problem using the first method, which is the regression-based imputation method, and these are the two methods which I recommend. So basically, regression-based imputation method usually use the multiple regression model, which try to learn different variables, try to conduct the multiple regression method, and then coming up with a pattern which can help us to replace missing values. So that is technically the case, but now the expectation maximization algorithm method, we usually use the expected values in order to try and fix the missing values. Then as you notice, we usually have 3 types of missing value. One of the type of the missing value, but this is not too serious or nothing you need to write. We have technically 3 methods which missing value can occur. So missing values can have a random occurrence of missing values. Then we can have an random occurrence of missing value, and then we can have a complete random occurrence of missing value, which technically is adopting some certain pattern. But you don't have to cram all these things since we have this software. So in order to do the first method, which we usually use to fix the missing value, we will be using the regression-based imputation method, which I usually recommend, which is technically I said to use the multiple regression model, which is more efficient since statistically it is usually correct. So what you're supposed to do, you're supposed to click analyze. Then you're supposed to come to where we have missing value. So your data will be here since we had taken all the variables, or we have chosen to use all the variables. So technically you'll be creating a new data set which will not be containing now the missing values. So what you're supposed to do, we want to start with the regression-based imputation method, RBI. We shall just click estimation method. We'll be using the regression. Then you click where we have regression. Then you save completed dataset, or save a complete dataset. Then we will rename this dataset as RBI. Then we shall hit continue and then OK. So when we do this, when you notice that you notice we have we shall be having, let me show you. We shall be having these tables showing you different regression models which have been conducted. So, but you can see we have a matrix table here showing us how different regression models have been conducted using the variables which we have in our data set. So we have regression correlation, but you don't have to cram all this. We can come here and see now the new data set which have been created. So you can see the new data set which is here, entitled to RBI, which represent the regression-based imputation method to replace missing values. So the new data set, to notice the new data set, you can use these commands which have been learned here, or this title which is here, RBI, IBM statistics. So RBI, we have said, is the regression-based imputation method. So you can notice now we don't have missing values. In order to confirm that your data set is free from missing value, you can use the method which I demonstrated to you. Just click analyze, then come to where we have missing values, or missing value analysis. We have said it is analyze. Then you come to where we have missing value analysis. Then we said we need to use all the variables. Then we can click OK, and we can come to here and check our output. So you can notice this method which we have used, the multiple variables analysis, which is here MVA, or what I have told you we call it the regression-based imputation method. You can notice now when we come to the missing values, you can notice the count is now 0. The missing value, we have been able to solve this problem using the regression model by running the regression models, the multiple regression model. You can notice we don't have missing value again. So what I would like us to do first, we shall then do these fixing of missing value using now the expectation maximization algorithm method, EMA method. So using the EMA method, then we'll compare if there is a significant difference between the original dataset, the dataset which you have corrected the missing value using the regression method, and which you have used the expectation maximization algorithm method. So let us now do the second method, which is the EMA method. Let us click analyze. Then we come to where we have missing. So we need to use the original dataset which was having missing value. So let us get back into our original dataset, which is here. So in order to notice we are in the original dataset, it will be named as dataset A, and it contains missing values. As you can see, we have missing spaces here. So that is how we usually do. So you can do it at the same time, but for simplicity, I decided to do it as separate so that you can be able to grasp the concept. So now we need to use the expectation maximization algorithm method, the second method which I would recommend you to be using. So you need to hit analyze, then come to where we have missing value analysis. Then already these values will be pre-populated here. Then we need to select EMA. Then I'll deselect regression since we have done the regression, so that I minimize the dataset which you'll be having so that you are not confused. Then you come to where we have expectation maximization, EM option. Then save a completed dataset. So we shall name this dataset as EMA, which is expected maximization algorithm. Then click continue, then click OK. So as we have said, a new dataset is being prepared, so the processor is ready. So you can notice here now, rather than the RBI dataset which we previously had, now we have EMA dataset. So the EMA dataset, the expected maximization algorithm dataset now, which have corrected the missing value problem, you can notice also we don't have any missing value in our dataset now. Our dataset is now clear with no missing value. So in order to check if in case there is an error or you have any missing value, as we said, now we have done this is dataset under the expectation maximization algorithm EMA. You need to click again analyze to check the availability of missing value, then click missing value analysis. Then you can use all the values and then click OK. So we can come here and check our output window. So under EMA, which is here, this is the command which we have run, you can notice we no longer have the missing values in this dataset. So what I would like us to do first, we need to compare. Technically, we can compare the mean of the dataset which we have corrected the problem of the missing value with the original dataset. So since I know these tables, they are somehow too comprehensive, I want just to compare their means. using Microsoft Word and see the different means which we have, and we see if there is any significant difference between the mean of the original dataset, the dataset which you are corrected missing value using the EMA method and RBI method. So let us get into the activity. So let us get into the original dataset, which was here. So you can notice this is the dataset which was having missing value. So then what we can do, so I would recommend you allow me to just close this output window. I just remove it. Then allow me just to close it. I don't want to save it. I want us to close it and start a new output window. So, since I want it to be simplistic, I don't want you to be confused by this output. Then what you need to do, we need to hit analyze. Then come to where we have descriptive statistics. Then choose frequencies. Then we can try and counter check the mean of the variables which had missing value which was alarming. That was the marital status, which was above the set threshold of 5%. We also had the address, which was also above the set threshold of 5%. We also have the income, which was also above the set threshold of 5%. We also have the employment, and we also had the retirement. So these are the variables which were raising alarm. So the first variable was the marital status, so we put it here. We want to compare their mean, where we had missing values, and where we did not have, and the dataset which we have fixed using these two methods. So this is the original dataset. So the variables which were raising alarm is the marital status. We also had the current address. We also had the household income. We also had the retirement. And we also had retirement, and we also had problem with retirement, household years with the current years with the current employment, and I think those are the data set which had which were the missing value was so significant that they exceeded the set threshold of missing value of 5%, the 5% of the observation which was carried out. So we don't want to display the frequency table, so we want just to generate a simple statistics. So I'll be comparing the mean of the original data set. So I just click continue. So there is something which I want to show you here. Then I'll click OK. So let me and check something here. So it's good. Then we shall just hit OK. So we can come here and check the output window. So we will take these, we'll copy these dataset as an image, which we will come and put it in Word. So let me show you something so that we can be able to identify the impact of missing value in our dataset, or in case we do this method, if we affect the results match. So we can name this one as the original dataset, or we can just, for just avoiding a lot of writing, we can name it as original. But I wanted to see if we can, or original, so we can just write ORIG to abbreviate original. Then we want to take the dataset which have no missing value, which we use the RBI, the regression-based imputation method. So let me show you what I want us to do. So let us open this dataset. So we shall just do the descriptive statistic of this dataset. Click analyze, then click descriptive statistic, then come to where we have frequency. So the dataset which was raising alarm is the marital status, the years at their current the years at current address, the household income, people cheated about their income, what they obviously do, the retirement, and the years with the current employer. Then I'll click statistics. Then we shall just use the mean and compare the mean of the data set which we have solved the problem of missing value. Then click OK, then click OK. Then we need to get the output. So this is the output as per the RBI, or regression based imputation method. Then I'll copy it as an image, and then I can come here and attach it in Word, and so that we can do the comparison. So let me paste the image here. So we shall name this output as RBI. Then we'll do the last one, which we use the expectation maximization algorithm, which is here. So what we are supposed to do, we shall just click analyze again, then come to where we have descriptive statistics, then choose frequency. Then we shall take the variables which were raising alarm, which is the marital status, years at the current address, household income, retirement, and the employment years with the current employer, which obvious a lot of people must check. Then from there, you can create statistics and then allow just to compare them. I want to deal with the mean for simplicity. Then click OK. Then we can come here and check our output. So this is the output of the mean of these variables using the using the EMA method, the expectation maximization algorithm method. Then we can copy this image here, bring it here in Word, and for comparison, drop it here, and we can name this image as EMA, which is here. So you can now, I need us to do a basic analysis here. So you can see here we had a varied number of observation which is 885, and a missing value of 115 for marital status, address 850 and 150, 821 and 179, 816 and 84. So when we try and compare their mean, you can notice that the mean of the original data with the mean which we had computed using the regression based imputation, they technically have a slight difference of 1. So you can also notice of 0, that is 0. Is it 0.1? 0, so it is 0.48 minus 0.49, which is a mean difference of 0.01. You can also notice that when we use the RBI, the regression based imputation method, and the expectation maximization algorithm, you can notice that the mean of the marital status is the same. When now we come to the next case where we are dealing with the years, when you use the original data, we can use the years of the current address mean is 11.47. But when we use the RBI, there was a slight difference, which was technically the regression based imputation, it is equal to the original. And then when we use the EMA, the expected maximization algorithm, you can notice the mean reduced to with close to, this is a straight difference of 0.1, which is 11.46. So now when we come into where we had household income in, and now you can notice here the number of missing observations have increased to 179. You can notice the original mean was 71.1462. But when we ran it using RBI, the regression-based imputation method, you can notice the household income mean changed to 73.7904. And when we use the expectation maximization algorithm, we receive a mean of 76.0752. So I think you can be able to see the slight difference between the mean when we had missing value and when we use the different method. But according to me, I usually recommend the regression-based imputation method and the expected maximization algorithm. But if we are running some econometrics models, RBI, the regression-based imputation method, is one of the best. That is what I usually recommend when doing your research and projects. So you can adapt the regression-based imputation method to fix missing values using SPSS. So that is the methods which we usually use to fix missing value or missing data in SPSS. So you can even test to use the pairwise deletion